Hey, welcome back to the video series, and I am so glad to be working on this segment on seed oils. I mean, honestly, this is what inspired me to even start doing the channel in the first place, because the information seemed to be kind of conflicting between the health gurus. I was like, wait a minute. You mean to tell me there's not a consensus or a full agreement that these seed oils are bad for the body? Like, I'm so glad that there's individuals like Nutrition Made Simple that will give contrast to some of the other health experts that are definitely have a position against certain subject matter. But in this particular case, I really believe, and I'm going to let you as the viewer decide after watching the content, but I really do believe that Nutrition Made Simple may be leading a lot of us down the wrong pathway. And that could be dangerous, at least ways for a community that's trying to get an overall consensus or idea on what they should do with their health. So I, just as a side note, I went through the entire video and I made notes and made up points with certain things that some of these gurus were bringing up or experts. So spend some time, look at what I wrote, and you might find a better way to make a decision in your own health journey, or maybe there's some areas you didn't even consider. But hope you enjoy the content. Hope you enjoy the video on seed oils. Let me know what you think in the comments line. And as always, enjoy.
Are seed oils inflammatory? Do they trigger inflammation? This is probably the #1 question we've gotten over the last several months. So today we look into it. Now I know there's 9,000 other questions about seed oils, but in order to make sense of things, in order to get some clarity, we need to tackle things one question at a time. So this video is exclusively focused on inflammation, all right? But feel free to ask any other seed oil questions below in the comments. In insulin resistance, oxidation, weight gain, whatever you want, and we can make videos on all of that. We'll start by looking at the effect of different types of seed oil on inflammation. What has the science figured out? Next, we'll look specifically at heated seed oil, which is a very common question. If you cook with it, does that have a different effect on inflammation? Third, we'll look at a little bit the why, the underlying reasons for the effects of seed oil on inflammation. And lastly, we'll look at individual variability, susceptibility. What is known about that? Let's get to the real stuff. Next up, we have canola oil, aka rapeseed oil, but that name sounds terrible, so they came up with this alternative name, canola, which is a contraction of Canada oil, and it just sounds more consumer friendly. And canola is high in monounsaturated fats, kind of like olive oil. And it's about 18% linoleic acid. And with canola, I start to see a lot of controversy and a lot of people scared of it and asking if it's inflammatory. So in this trial, people were asked to add 1 tablespoon a day of canola oil to their food for 2 months. And CRP, C-reactive protein, was not significantly different after the exposure to canola oil. Another really common question is, how do these oils compare to other types of fat, like saturated fat, for example? So this trial compared saturated fat with omega-6s. They gave people similar foods but replaced saturated fat with unsaturated fats using canola and sunflower oil, which we're going to look at in more detail in a minute. The omega-6 intake was roughly doubled in that seed oil group, and there was no significant difference in several inflammatory markers, CRP, IL-6, and interferon, after the exposure to seed oil or compared to the saturated fat group. This other trial compared canola to olive oil, which is considered much better by a lot of people. So it's an interesting comparison. And they actually found a reduction of CRP both on the canola and on olive oil, and no clear difference between the groups. So far this sounds kind of similar to the flaxseed oil picture. Most trials don't find much of a difference, and then a few might suggest a reduction. Now let's look at some meta-analyses to get a sense of the big picture. This systematic review and meta-analysis looked at 42 randomized controlled trials using canola oil, and it found no significant effect of the oil intervention on inflammatory markers. And it also looked at comparisons between canola oil and other specific oils, for example, olive oil, and there was no significant difference in CRP level between the two. So that's canola. But again, canola is mostly monounsaturated fat, only 18% linoleic acid. So if linoleic acid is the real problem, canola wouldn't be the best test anyway. So let's just keep going up and up. Next, we have sunflower seed oil. There are many types in the market, but the standard type is 20% linoleic acid. So here's an example. In this trial, people were told to consume 1 tablespoon of sunflower oil every day in the morning for 4 months. And it was double blind, so they didn't know what type of oil they were eating. And a really interesting particularity about this trial, a lot of trials don't give a ton of detail on the oil they use, but this one specifies it was refined oil, which is usually treated with chemicals and heated, and not the cold pressed kind that some people believe to be safer. So this could be a more stringent test of the safety of these oils. And people consuming it did not have a significant change to CRP level after the 4 months. Quick note on compliance. A lot of these trials provided the oil to the subjects in a bottle, and then after the intervention, often they collect the bottle with whatever's left so they can kind of see how much was consumed. Some trials go beyond that and actually measure the blood levels of some fatty acids in the participants, because those change depending on the fats that we eat. And other trials go even farther beyond that, and we'll look at some examples in a minute. So here's another example. We're still looking at sunflower seed oil. This trial asked people to consume about 2 tablespoons every day, added to their salad or rice or other foods. And at the end, did not see a significant effect on CRP level. Here's another one that compared sunflower seed oil to isocaloric saturated fat, mainly from butter. Some inflammation markers actually seemed lower on sunflower seed oil, and they even concluded a high omega-6 polyunsaturated fat intake does not cause any signs of inflammation. Instead, omega-6 polyunsaturated fats may act as anti-inflammatory. Okay, but that's just one isolated trial, and this is their phrasing. Who cares, kind of. So what do the meta-analyses show? This one looked at 9 trials on sunflower seed oil, and there was no significant change to several inflammatory markers: CRP, TNF, IL-6, and ICAM. So that's a look at sunflower seed oil. Okay, let's get to the big cats. 50% and over linoleic acid, soybean, safflower, corn oil. This is where the rubber meets the road. And these are some of the most controversial seed oils out there. So next I looked at soybean oil, which is about 50% linoleic acid. Here's one trial where patients were on parenteral nutrition, which is where you get your nutrients diluted in a solution and straight into your bloodstream if you can't eat for some reason, maybe right after a procedure. So this is really interesting data to look at among other types of administration, because number one, you know exactly how much is going in. And number two, it's going straight into your blood. So if there's an issue with these oils, it might cause a problem there. So they split the patients. Half were getting an olive oil-based solution, half were getting a soybean oil-based solution. So there was a 5-fold difference in soybean oil intake between the two groups. And they received these intravenous infusions for 3 months. And it was also double-blinded, so they didn't know which one they were getting. But C-reactive protein level was not statistically different between the two groups. Okay, so that one is kind of cool to look at because they're injecting the oil straight into the bloodstream in a way. But at the end of the day, we want to look at normal administration, eating it. So this trial compared soybean oil to flaxseed oil and fish oil. So 3 groups, all delivered in capsules. And people took them for 2 months. And at the end, there was no significant change in inflammatory markers on any of the oils. Here's a recent review that summarizes the evidence on soybean oil. They say soybean oil is the leading edible oil consumed globally and in the US, and they conclude it has no significant effect on markers of inflammation. They elaborate a little bit. Evidence to date convincingly indicates soybean oil does not increase markers of inflammation. Okay, so dose doesn't seem to make a big difference. What about time? Maybe these oils seem fine inflammation-wise over weeks or months, but if you eat them for years and years, then you pick up an inflammatory signal. A little strange because inflammation normally kicks in pretty quick after a stimulus, but it's possible. We'll look at some longer trials in a minute in the scale of years, but another thing we can also do is we can ask if people who normally eat larger amounts of linoleic acid in their normal lives, if they have more inflammation. What's been reported is that higher linoleic acid intakes are associated with lower concentrations of C-reactive protein, IL-6, and IL-1 beta, inflammatory markers. So the opposite of what would be expected if they were pro-inflammatory. Now, maybe people are not being honest and they say they eat a lot of linoleic acid, but they really don't. So we can ask this question in a different way. Linoleic acid is an essential fat. That means our body doesn't produce it. We need to get it from our food. That also means that whatever linoleic acid is in our body came from something we ate, since we can't produce it. So we can measure people's linoleic acid levels in the body and see if that goes in the same direction as the dietary intake data. And what they found was an inverse relationship between circulating levels of omega-6s and inflammatory biomarkers. That means the higher the omega-6 levels in the body, the lower the inflammatory markers. So it matches the dietary intake data, and again, the exact opposite of what we would expect if the omega-6s were pro-inflammatory. So that's the general picture regarding seed oils and inflammation. Next, we're going to look at heated seed oils, which is a very common question. Okay, let's talk about heated oil. Really common questions a lot of viewers ask, so I really dug. And there are less studies on heated oil specifically. Not surprising, anytime we ask a more specific question, there's going to be less data. But I did find a few. So this one, for example, was a randomized controlled trial. People were given either peanut oil or corn oil to cook with and to replace their normal cooking oil. And after 6 months, there was no significant difference in CRP level in either group. This one was similar, but compared sunflower seed oil to coconut oil, also for cooking, and it lasted 2 years. And there were no significant differences in CRP at the end. This one's very interesting. The level of control they had was unusual. 3 meals a day were prepared by the research team and provided to the subjects, all cooked in soybean oil, breakfast, lunch, and dinner. For 2 months, the researchers visited the subjects, served every meal, and checked their compliance. So they checked that they actually ate. And many of the meals were fried. Fried fish, fried rice, stir-fried vegetables, all in soybean oil. And they measured several inflammatory markers, and eating all that food cooked in soybean oil did not significantly change any of them. Now, maybe light heat, like sauteing or something, is fine, but intense, prolonged heating is what blasts these oils. In fact, it has to be that way, right? If you heat anything long enough, you heat a stick of celery long enough, eventually it becomes a lump of coal and it's not good to eat. So it's just a question of how long it takes. And this is such a common question that I really wanted to dig more into this, so I kept looking for trials that looked at more prolonged forms of heating. So in this randomized control trial, they gave people safflower oil, heated safflower oil, or olive oil in capsules for 1 month. And the heating procedure was 2 hours at 240 degrees Celsius. So pretty intense. And it was a blinded trial, so they didn't know which one they were getting, and there was no significant difference in inflammatory markers on any of the groups. Okay, what if we deep fry the oil? I think that's what they do at Burger King and places like that. That has to ruin it. I mean, it's just a matter of time. There's no doubt. Now, at this point, it was getting harder to find trials that did it because it was a more and more specific question. But I did find some that deep fried the oil for an extended period of time. But at this point, most of these trials look predominantly at acute effects after 1 meal. This one used sunflower seed oil, deep fried for a whole hour, and then stored in the fridge until it was consumed. A bit atypical, I think, but okay. And they had 2 groups, healthy people and people with heart disease. In the healthy ones, there were no significant changes to the inflammatory markers with the unheated oil or with the deep fried oil. But the folks with heart disease, it was interesting. The unheated oil lowered some of their inflammatory markers, and the deep fried oil raised some of them. Now again, this is only an acute effect after 1 meal, so it's entirely possible, I would say it's plausible, that if someone ate that stuff consistently for a while, yeah, the effect might be much stronger. I mean, that's what I would expect. Or if you deep fry the oil repeatedly, right, over and over, I think that's what they do in some of these fast food restaurants. So I did find a group in Spain that does the experiment like that. They deep fry the oil and then let it cool down and then deep fry it again 20 times in a row. The same oil sequentially, right? And then give it to people. Now, don't ask me how much they're paying these volunteers to go through that. I don't know. Unfortunately, in this experiment, they don't look at inflammatory markers in the blood, and it's only an acute effect after 1 meal, right? I don't know if you could give this stuff to people chronically for months. It's probably not ethical. But they do report some molecular changes that suggest that olive oil might resist that insult better than regular sunflower seed oil, and that you might be better off if you had to eat something deep fried 20 times, that you might be better off, that it might be healthier to do it with olive oil, and I have no trouble believing that. So when we put everything together, we have a very strong balance of evidence that seed oils in general, unheated seed oils, don't show a clear effect on inflammation across 7 or 8 different types of seed oils with widely different linoleic acid contents in different doses in sick people, in healthy people. Cooked seed oils, for the most part, also no clear effect on inflammation, even after cooking exclusively with seed oil for months or even years in some cases. When we get to extreme exposures, like deep frying for hours or deep frying the same oil for dozens of times, then we might have an issue. Some data suggests that. I'd be surprised if that weren't the case at some point. So that's the data. Now this is for seed oils themselves, not junk food that happens to contain some seed oil. Sometimes I see people online conflating this, saying, I cut out junk food and I felt better, I got healthier, must have been the seed oils. Oil on a salad or to saute something is one thing, and junk food, with or without seed oils, is a completely different beast. Let's get that very clear.
On this week's podcast, I had my friends Tucker Goodrich and Jeff Knobb. Jeff and Tucker have been collaborating on some amazing blog posts at Zero Acre. That's Jeff's project that you will hear about in this podcast. But we went deep down the rabbit hole of seed oils. We talked about studies that people would levy or would advance to say that seed oils are fine. We talked about the conflicting side of the arguments, and we spent a lot of time talking about why seed oils are likely to make you fat, why they are likely making you diabetic, and why they are likely giving you atherosclerosis, heart disease, which leads to heart attacks and all these things. So this is a really cool discussion with Tucker and Jeff about seed oils. You all know, if you followed my work for any amount of time, that I believe these are at the center of chronic illness for all Americans, for people worldwide, because there's an epidemic of seed oil consumption in this country. It's completely evolutionarily inconsistent, and the literature is confusing. So hopefully we were able to sort out a lot of that for you guys and make it much more clear. When I was recently in Phoenix, Arizona, I did this bit of content where I went to a number of semi-fast food restaurants. I went to Chipotle, I went to a Mongolian grill, I went to a restaurant, and I asked them what cooking oils they use under the guise of saying, oh, I have an allergy to these oils, because I think after this podcast, people could say that most humans probably have a quote unquote allergy to seed oils in some way, shape, or form. But I asked them, what oils do you use? And they all used seed oils invariably. The only place that did not use seed oils was Smashburger. And we found out later they actually do use canola oil, but didn't tell me they use canola oil. So the Mongolian grill said they cover the grill in canola oil. They soak it in canola oil at night. They said, you can't ever eat here if you have an allergy, because literally our food is just totally drenched in canola oil. All the other like Yogi grills and stuff would either use soybean oil or canola oil. They use it in the fryers. They use it on their grill tops. The restaurants would say they use olive oil and canola oil. When you actually look at the olive oil, it's usually pumice oil, which is not good quality, or extra virgin olive oil. It's not like a cold pressed olive oil. Went to a Greek place. It's the cheapest, worst olive oil, quote unquote, you can get. But they say olive oil. I went to Chipotle and they said it's rice bran oil, which is actually pretty high in linoleic acid. And then they kicked us out. You can't film here. You can't film here. And
oh man. All right. So, we don't want this podcast to be 6 hours, right?
No, we don't.
I'll give the abridged version. And so what are seed oils? Seed oils compared to vegetable oils, those terms are kind of used interchangeably, but technically, vegetable oils are the broader category of any oil that comes from a plant or a crop, whether that's olive, palm, avocado, coconut, or corn, canola, soybean, sunflower. Seed oils are a subcategory of vegetable oils that include oils that come specifically from seeds or grains, which are technically the seeds of grasses. So sunflower seed oil, rapeseed oil, also known as canola oil, soybean oil, rice bran oil, which is a grain or seed. That's what seed oils are. And we talk about linoleic acid and omega-6 fats a lot. And the reason that those terms are somewhat synonymous with seed oils is because seed oils have by far the highest content of these fats. And these fats are found in all foods in very low amounts, but in seed oils, they're found in abundance, orders of magnitude more than in any other food. And so throughout this conversation, I'm sure we'll be talking about linoleic acid and omega-6 as well as seed oils. And I think we can kind of use that interchangeably for that reason.
And a high level, why do we think they're bad for us?
Yeah. So I think it starts with evolutionary precedence. And nutrition is probably the worst form of science, and that most of our nutrition science today is driven more by politics than actual science. And there's actually very little that's scientific about how we currently make nutrition decisions. So it's helpful to have other frameworks that we can look at to figure out what should we be eating. And evolutionary biology and our evolutionary precedent is an important one, as is looking at the diets of human populations that aren't sick and aren't obese, and looking at what they eat and what they don't eat. Those I think are really valuable frameworks, at least as a starting point. So why are they bad for us? First and foremost, there's no history of humans eating them. And usually when we introduce new molecules and compounds into our diets in unprecedented amounts, it doesn't end well for us. And I think linoleic acid and seed oils are no exception. So purely from a precedent standpoint, we haven't eaten them. And any human population that starts eating seed oils inevitably becomes sick and obese. And then similarly, there's no human population that's sick or obese that doesn't consume seed oils in meaningful quantities. So that at the very least should throw up the red flag that there's something worth looking into here. I will say, there are some studies sometimes that show some individuals are healthy and they eat seed oils. I think, I liken it to smoking cigarettes and cancer. There are plenty of individuals who smoke cigarettes, smoke tobacco and don't get lung cancer, but there's no population that picks up cigarette smoking in large amounts that doesn't also have increased rates of lung cancer. So at a population level, something is going on here. And then you kind of take it to the next step of, more observational studies, people who tend to have more dietary linoleic acid, what are their outcomes? They tend to be worse. Take it a step further and look at randomized controlled trials. And there are several randomized controlled trials showing far worse health outcomes, whether it's obesity or heart disease or all-cause mortality, with increased consumption of seed oils. And we can talk about some of those. And then, so kind of broadly, population level data to observational studies to randomized controlled trials. And then from there, there's also just common sense of how much real food you would have to eat in order to actually get, the amount of oil that's in like a restaurant meal or a bag of chips. And then, Tucker could wax poetic on all things mechanistic data of what happens when we actually eat seed oils. But I mean, there's fascinating research there showing high linoleic acid seed oils. It's not just the linoleic acid, but what does that linoleic acid turn into, either in the frying pan or in your body? And what that linoleic acid turns into is potentially far worse than the linoleic acid itself, and sort of objectively, uncontroversially toxic. More so chronically than acutely, like ingesting arsenic, but still toxic. And then the last point I'll just make, is we're typically using seed oils to cook our food. And many of the studies that are done on seed oils are in a fresh state, uncooked. And that's probably not appropriate, since we mostly eat cooked seed oils, and seed oils go from bad to far, far worse the longer that we cook them. And there's all sorts of data showing that as well. And the last point I'll point out, just because I think it's underappreciated, is how bad seed oils are for the environment. And there's so much talk of red meat being bad for the environment. Vegetable oils, broadly speaking, are they take up more land than any other crop, and they're about a third of global croplands, and lead to all sorts of issues with biodiversity loss and deforestation. And again, uncontroversial. It is the data is very clear. We're destroying a big part of our planet to grow these crops that end up ultimately doing us harm and killing us.
When you start looking at this on a population level, there are no populations that avoid seed oils that have the health problems with the chronic diseases that those populations that have high levels do, right? I've asked people, I've yet to find a single exception. When you start getting into trying to figure out what a ubiquitous element in the food supply is doing, as most epidemiologists are doing, if you're looking at people in the United States, everybody in the United States has been consuming high amounts of seed oils for over 150 years, right? So, and what the science clearly shows is that the negative effects of these seed oils seem to start at fairly low amounts. So if you're saying, okay, well, everybody in America roughly eats 7% seed oils and some people are doing okay, you know, the number of people in the United States who are metabolically unhealthy, the highest number I've heard is 92%. So we're, you're doing epidemiology looking at a almost entirely sick population. And it's super difficult to take that and turn around and say, well, these aren't problematic because look, 8% of the people are healthy and they're eating seed oils.
Super, super important points. And I love that in the white paper on seed oils and obesity on the Zero Acre blog, you guys start with a discussion of this anthropology, and you point out the chimene. So I'll let whoever would like to talk the story of the chimene or the Simene, the Bolivian Simene, and their exposure to seed oils. But I think this anthropology is a good framework for this discussion. And I love what you guys both pointed out, that indigenous hunter-gatherer type populations generally don't consume, I shouldn't even say generally, consistently, invariably do not consume more than 2 to 3% of their calories from seed oils.
And what there is one exception to that, and we'll get into them.
Okay. And
because it's the exception that proves the rule, in my opinion.
Perfect. Yeah, you can tell us about that. And that the American population is 7 to 10% of our calories from seed oils. Now, 2 to 3% versus 7 to 10% may not sound like enough, but it's or a lot, but it's really important to understand that perhaps the actual effect of those oils is seen between that range. And so going from 8 to 10% of seed oils or linoleic acid in your diet may not actually have a negative consequence, which is what really understanding the nuance of the research is. So yeah, if you guys want to talk a little bit about these indigenous populations, what they're like in terms of health and what happens when they're exposed to these oils, I think that's a good place to start, sort of anthropologically.
I'll let Tucker speak to that. Just want to clarify, Paul, the 7 to 10% number is linoleic acid in our diet.
Okay.
And it's more than twice that for seed oil consumption.
Perfect. Thank you.
Yeah.
Big jump from anthropological levels.
So the chimene, I've heard it pronounced different ways, but we'll go with that, are a population living in the Amazonian rainforest in Bolivia. They are the favorite population at the moment of cardiologists because the cardiologists went down there and discovered that they have essentially no heart disease, the lowest of any population ever explored, right? So and of course, they don't have the other things that tend to go along with that. They don't have obesity, very low rates of obesity. We'll get into that. And then they don't have diabetes. They don't have any of these other problems. These are poor people living in the jungle. They live by doing a lot of farming. They have a pretty high carbohydrate diet. Some of the interviews I've seen with them, they complain about how they can't get enough meat to eat. And so they're always hungry. But they are, by the standards of Americans, very healthy. And luckily, this is these folks in the Catawbans, who are a South Pacific group, are two of the populations that have been eating what you could call an ancestral diet, right? They're not hunter-gatherers. They're not, a model for the carnivore diet. These folks eat a lot of plant matter. But what they haven't been eating up until recently are what the research studies call market foods, right? They get their own food out of the Amazonian jungle. Then they noticed that things were starting to change. They initially noticed that there was a correlation between motorboat use and the beginnings of obesity in this population. And you might think to yourself, well, why on earth would having a motorboat make you fat? And the answer turned out to be because if you have a motorboat, you can go down the river and get to a store and start buying market foods. So they turned around and they went and looked at that's my wife trying to keep the dogs quiet behind me. They looked at what are these folks actually eating, and they found out that the correlation with obesity in this population is their increased intake of industrial vegetable oils that they are getting from stores. And like every other population on Earth, the more exposed they get to, industrial diets, they start eating the same foods, which means refined carbohydrates and processed foods and seed oils. So here's, these folks are in the process of leaving their ancestral way of living aside and going to a modern diet. And we're already starting to see the negative effects of that diet on this population. And what's likely going to follow are the same things that follow everywhere else, which is, heart disease. And in 20 years, we'll be reading papers about, paradox that Chimene eat a AHA approved prudent diet, and yet they have high rates of heart disease versus when they were, just living off the jungle and they were all healthy and paradisical. I mean, it's fairly entertaining to see this happen in kind of a sad way.
It's kind of like the Israeli paradox that Israelis eat a heck of a lot of seed oils, I think some of the highest amounts in the world, and yet have the same or higher rates of heart disease and diabetes and obesity as other parts of the world. Well, I don't understand. All of the paradoxes I've ever heard of are not paradoxes. How can the Eskimo eat so much fat and not get heart disease? Well, because they're not eating processed foods. How can the French, right? Like none of these paradoxes, the Eskimo paradox, the French paradox, none of these seem like paradoxes from an ancestral evolutionary perspective, but when viewed through the lens of what is widely considered to be a quote unquote healthy diet, they're all paradoxical, which is just, I don't understand why people don't realize, like, wait, maybe we just have, maybe the lens, maybe the whole overarching paradigm is wrong. Tucker, what is the exception to the rule regarding the hunter-gatherer or indigenous populations that you were mentioning earlier?
It's the Bushmen in Africa. The
Kung?
The Kung. Thank you. I mean, I guess I could try clicks talk, but I'll skip that. So let's just call them the Bushmen because I can pronounce that. They seasonally eat something called a mongongo nut, right? And the mongongo nut, like most seeds, has a high amount of linoleic acid in it. So seasonally, when they're eating these nuts, they get high amounts of linoleic acid. And what does that do to them? Well, it makes them insulin resistant. They can't pass an oral glucose tolerance test when they are on the mongongo nut part of their diet, right? So the only ancestral group we have who does not eat a low seed oil diet is the only ancestral group we know of that can't pass an oral glucose tolerance test. And that includes folks like the Eskimos, the Inuit, who've never seen a carbohydrate bigger than a blueberry. And nevertheless, they are perfectly able to pass an oral glucose tolerance test. So we're left with this one little group who eats lots of mongongo nuts seasonally because they have nothing better to eat. They would prefer to eat meat, but they can't. And they fail an oral glucose tolerance test. And when you take them out of that environment, if they go into, I guess the equivalent of a reservation there where they're no longer eating these mongongo nuts seasonally, then this diabetic effect of the nuts goes away, or what seems to be the nuts, in my opinion.
There are a number of studies that show increased consumption of linoleic acid and seed oils do lead to weight gain. And so then the question is, why does that happen?
And that's in animals and in humans.
Yep, exactly. And one explanation is what you're describing, Paul, that it could be an evolutionarily conserved mechanism from small rodents to other primates and potentially even in humans, where winter is coming, time to put on weight to stay warm in a time of food scarcity in winter. And so around fall time, there are nuts and seeds that are available for consumption, maybe some grains, and we consume more of those, and our bodies get the signal that it's time to put on weight. And there are interesting examples in other mammals and in other animals where they're actually unable to put on weight and enter hibernation unless they consume more and more linoleic acid. So if you take that to the practical extreme, it's that humans are in a constant state of hibernation and weight gain because we're constantly preparing for winter. And if other animals are any indication, if without that increased amount of linoleic acid, we're not in a state of hibernation, more energy, more aware, less weight gain, that's one hypothesis that we talked about in the white paper. Another is that there's no intentionality. It's simply something's gone wrong and something breaks, and that leads to increased fat storage. And that gets into what linoleic acid turns into in our body and how that toxin starts breaking things and leading to fat gain. And that's less about an evolutionarily conserved, intentional mechanism, and more just about things going wrong.
Now, do you want to add anything to that, Tucker?
I was going to say, even that effect that Jeff's describing is evolutionarily conserved. They've shown it in bacteria and roundworms and all the way up to humans. So it seems to be, what we're talking about here really is fundamental processes that we've kicked sideways by overconsumption of these fats, right? Even some of the toxins that we're discussing, HNE, which is probably the best studied oxidative product of linoleic acid, has signaling roles in the body, right? It's, a fundamental part of our metabolism, but it's supposed to be there in a certain quantity. And we have, by dumping excess linoleic acid into our bodies, we seem to have increased the amount of this toxin. And everywhere you look through chronic disease, every single chronic disease, this toxin is thought to play a role. And so it shouldn't be surprising that if you evolve, just like in human history, we evolved in a tropical climate, and then we decide that we want to move up to the Arctic. And we had to make a lot of changes, and there were a lot of, genetic adaptations. It's entirely possible, one could argue, that we're going through another genetic adaptation to a high seed oil diet. But just like, the first folks who moved to the Arctic Circle probably didn't do all that well until they figured out about, mucklucks and parkas and things like that. In the meanwhile, as you're trying to make this adaptation, you're going to suffer from it. That's how evolution works, right? If you're eating evolutionarily appropriate levels of probably any fat, you're going to do just fine, right? Because that's what the system was designed to handle.
Tucker, do you want to bring us down the HNE rabbit hole for a few minutes? Because I think this is a really important one for people to understand. Right.
So HNE is 4-hydroxynonenal, and I will not say that again in this podcast. HNE is when you oxidize a linoleic acid molecule, it breaks in half, and that's half of it, right? HNE. Now, HNE is a great marker of the negative health effects of linoleic acid because it's only produced from linoleic acid, right? There are other markers that they use that can be produced from omega-6 or omega-3 fats and, different types of markers. This one is specific to linoleic acid. And in the context of obesity, it's very interesting because when they first discovered and started exploring HNE, which was discovered, I'll mention, in the context of cancer research, they started adding it into, treating basically cell cultures with it. I think it was yeast. And they discovered that the yeast either died or got fat, right? So, which sort of establishes one of the important things about HNE is that it's toxic. It's a toxin. I mean, that's not my opinion. That's how it's listed everywhere you'll ever read it, right? In large amounts, this is a toxin. It also alters how your body, or if you're a yeast cell, your cell processes energy, and it predisposes you to storing fat, right? So a continuous supply of HNE, which you would only get in a lab or if you're eating the modern American diet, is going to predispose your body to constantly storing fat, right? And they've discovered in these animal models that when you stop the flow of HNE, this process stops. But unfortunately, in the context of the modern American diet, you can't stop it because you're constantly eating it, as you mentioned earlier, right? Every meal you're exposed to these fats and they're breaking down into these toxins in your body. And it's probably why one of the more interesting epidemiological studies that I've ever found found that the most fattening food that Americans eat by a huge, by 6 or 7 fold is French fried potatoes. And one of the things that happens to the vegetable oils when you fry anything in it, but particularly potatoes, is that it breaks down into this obesogenic toxin, HNE.
The amount of HNE in French fries is pretty enormous, isn't it? I was looking for a study that you actually referenced the study in the blog post, and I was looking for the study because there's actually studies on HNE in French fries.
In French fries, in any fried food that's, where you're frying linoleic acid, it's going to break down into HNE and other toxins. And, some of them are obesogenic. Some of them are thought to be carcinogenic. HNE, when they were trying to figure out exactly why LDL causes atherogenesis, the answer that they came to was HNE, right? Because of the damaging effect, the toxic effects that it has in the body.
Now, okay, I want to come back to linking LDL and HNE. I want to highlight a few things that you said, that the source for HNE in the human body is linoleic acid. That's where it comes from. It's not coming from anywhere else.
The only other place from omega-6 fats. So it can also be made from arachidonic acid, which typically you only have a tiny amount of in the body.
And perhaps we should have mentioned this earlier. The human body stores polyunsaturated fatty acids in the diet. So like chickens and pork and other monogastric animals, or chickens and pigs, and other monogastric animals, we don't have a method to get rid of polyunsaturated fatty acids. They end up in our adipose tissue in some proportional amount to our consumption. So
if we're consuming them vastly in excess, we actually do have mechanisms to get rid of them. And it's thought that the harmful effects is why. For instance, if you drink alcohol is a toxin. Your body preferentially starts burning the alcohol to get rid of it, right? You do the same thing with glucose, and you do the same thing with polyunsaturated fatty acids. And in fact, one of the things that your body does with polyunsaturated fats is it turns them into neutral, inert things like cholesterol or saturated fat. So your body knows, the body's a survival machine. It didn't, we've been around for how many billions of years? We got here because our bodies are good at processing this stuff and protecting us from harm. And if you eat polyunsaturated fats, one of the things your body does is convert them into harmless things like cholesterol and saturated fat that don't oxidize and don't become toxic.
So the outlet to the bathtub is not terribly large. The amount of polyunsaturated fatty acids flowing out, being converted, in a way, it's a bottleneck. I've only seen like one kinetic study on how quickly we turn over polyunsaturated fats. Let's just say omega-6 fats for this purposes of this discussion. And it was something like 680 days is the half-life, something astronomical. So who knows how long it takes for these things to get out of our bodies at the level of linoleic acid. So we can get rid of them. It's just a very slow process. Am I understanding that correctly?
Yeah, that's right. And there are certainly things you can do to try and accelerate the process. You've done lots of posts on the benefits of exercise and fasting and, but the best thing to do is avoid them in the first place.
And let's talk about beta oxidation and ketogenic or low carb diets, because I learned something reading the white paper that one of the ways that HNE is, or I guess perhaps the main pathway by which HNE is disposed of in the body, is beta oxidation, which is part of the process of ketosis.
Only in a ketogenic state is HNE oxidized. So yes, and I suspect that is one of the benefits of the ketogenic diet, is that it is allowing you to burn these toxins off as energy rather than having them go out and do damage throughout your body. And
that's very interesting.
Yeah. And they've shown this, in animal studies quite clearly, where, if you look at fat consumption in the context of an American diet, right, using the quantities, the types of fats that we're consuming, at the low end, they're not very obesogenic. In the middle, they're very obesogenic. But then when you start getting up to the high end, it starts curving back down. And it's part of the reason that it's probably curving back down and getting at a low point at a ketogenic diet is because it's burning off this obesogenic chemical.
That's interesting. So if you exclusively feed people polyunsaturated fatty acids, they go into ketosis and it burns off the HNE?
There's one
animal models.
little problem with that, and that is in excess, these fats are acutely toxic. They did a couple of human experiments where they fed people a lot of polyunsaturated fats to try and get them into ketosis, and they all got nausea, right? And nausea is a sign that you're eating a toxin, essentially.
It makes sense. Yeah. And I've talked on previous podcasts with Thomas DeLauer about studies with ketosis where they did more or less polyunsaturated fatty acids. I'd refer listeners to that one if you're interested. But when you are eating polyunsaturated fatty acids in those studies, it's kind of messing up the metabolism. I'll leave it there without getting too far down the rabbit hole. That's a negative thing for humans. So,
there was, just to kind of put the cherry on top of that point, there was a great study that I put on my blog years ago where they looked at, a high polyunsaturated fat diet in rodents, and they were lean and they didn't get obese, and everything looked great until they looked at their livers, and they were all suffering from massive liver failure. So they were fit and ripped and dying from the inside out. And, that's in the context of America suffering from a massive epidemic of liver disease that only started in the 1980s. So in your body, you have this process where arachidonic acid, where we mentioned before, in your gut is turned into endocannabinoids. And these endocannabinoids, if you want to make your body to make endocannabinoids and stimulate a hunger signal, the easiest way to do it is to not eat. And your body's reaction of fasting is to make these chemicals that make you hungry and make you want to eat, right? That's perfectly normal. And if you eat excess linoleic acid, then your body has more of the building blocks for these endocannabinoids because it converts linoleic acid to arachidonic acid to these hyperphagic, meaning they make you eat too much endocannabinoids. So we know that process. It's well described in animal models, and it's so well described in animal models that we had a drug to treat it called rimonabant. And rimonabant was introduced in the 2000s. It was considered a miracle drug. Interestingly, to get to our other white papers, not only does it eliminate obesity in animals or nearly eliminate obesity in animals, but in humans, it also improves all the cardiovascular and diabetic risk factors.
Tucker, can I just double down on what you said here? Because I think it's so important and you provided a lot of good detail. I'll try to do like the 30-second version just to hammer it home here. THC gives us the munchies, uncontroversial, but smoking marijuana gives us the munchies. And there are also cannabinoids within our body, endocannabinoids like AEA and 2-AG, that also stimulate CB1 receptors the way that THC does. And it's the activation of those CB1 receptors that makes us hungry. And increased linoleic acid intake in our diet increases 2-AG and AEA, which increases stimulation of CB1. And this has been shown, very clearly in rodent studies. And interestingly, this will take me over 30 seconds, but Paul, I think you'll find this interesting. Another in a follow-up to that, a study in mice showing that increased linoleic acid led to increased endocannabinoids, which led to weight gain and increased hunger. They also did a separate study where they fed salmon increased amounts of high linoleic meal.
And soybeans.
It's soybeans, yep. And then the salmon had higher amounts of linoleic acid in their flesh. And they then fed the salmon that ate high linoleic diets to a group of mice. And then they fed different salmon that was lower in linoleic acid to a different group of mice. And the mice that ate the salmon that ate the higher linoleic acid diet actually gained more weight. So if this is any indication for humans, it means, if we're eating chickens and pigs that they had the different, the high linoleic acid diet, even if we're doing everything else right, that could still lead to weight gain. But back to the THC or AEA and 2-AG to CB1 activation story. Carrying that over to humans, rimonabant, this study that Tucker's really done a good job of shining the spotlight on, that is how it works. It's not like one of 50 ways of how it works, and this is one little byproduct. That is why it is found to be such a miracle drug. And then when you look at bariatric surgery or gastric bypass, again, it is CB1, the blocking or lowering of CB1 activation in the gut. That is why it works. There are papers on this. We're not making this up. It's very clear. And then just to highlight one other point that Tucker touched on, if you directly administer the endocannabinoid AEA, which is one of those endocannabinoids that is increased with linoleic acid consumption, that reduces the fat loss of gastric bypass, which points to it is the same mechanism at play there. All of the things that increase our appetite, like THC, and all the things that really help us lose weight, even if there are side effects like bariatric surgery and drugs like rimonabant, they're all working on the same pathway here. And that same pathway is activated when we increase our consumption of linoleic acid.
The exact opposite is true of the cardiovascular disease post. There is literally no other explanation in the literature for what causes cardiovascular disease than the progression from linoleic acid to oxidized linoleic acid metabolites in the body, initiating and causing the progression of heart disease. I mean, there's a paper that came out recently. Here, let me just get the title in front of me. Low density lipoproteins cause atherosclerotic cardiovascular disease. And it's a consensus statement from the European Atherosclerosis Society. And it's got some of the most revered scientists in this field. And if you read it closely, when they get to the steps that are required to initiate cardiovascular disease, the very first step is the oxidation of linoleic acid in LDL, which converts it from non-atherogenic LDL to atherogenic oxidized LDL. And they reference a study that was done back in the late 1980s, if I remember correctly, where they actually concluded that line of research by feeding people, first rabbits and then people, either olive oil or seed oils, and then measuring the susceptibility of their LDL to oxidation. And it was clear that in humans, and there have been lots of studies done showing this exact same thing, that the amount of seed oils you consume predisposes your LDL to oxidation, which is the required step to initiate atherosclerosis. So that's a fundamental difference between those two posts, right? We are pointing something out that they have been saying privately in the journals for decades, right? There is no other explanation for what causes cardiovascular disease. As this article does, they will say, oh, it's LDL, but it's not LDL. It's only LDL when you have oxidized omega-6 fats in the LDL. That is the required alteration in LDL to make it atherogenic.
In the post that you guys have on Zero Acre, you also note that there have been experiments with macrophages, and that essentially, without getting too granular, within the arterial wall, beneath the endothelium, macrophages, these immune cells, live. And most people would agree that the beginning of atherosclerosis or plaque formation is a fatty streak. And even before that happens, we get these foam cells. And correct me if I'm saying any of this wrong, guys. And these foam cells are macrophages taking up LDL. But they're not just taking up any LDL, because when we've done the experiments, macrophages will not ingest, quote unquote, native LDL that is not oxidized. But LDL must be oxidized. There must be something that triggers this macrophage receptor to take up an oxidized LDL particle. So macrophages will not ingest native LDL. LDL must be oxidized to begin the formation of foam cells. And here we have a hypothesis, or perhaps it's even beyond that, a mechanism by which more linoleic acid in the human diet increases the amount of linoleic acid in the LDL particle. And if there's more linoleic acid in the LDL particle, that LDL is more susceptible to oxidation. And we know that oxidation is a prerequisite for the formation of foam cells, which are the beginning of atherosclerosis. Did I get all that right? I mean, what am I missing here? How can people not see this?
That's exactly right. And that was demonstrated by the gentleman who discovered the LDL receptor and got a Nobel Prize for it back in the 1980s, Brown and Goldstein. And the first thing that they tried to do after establishing this pathway existed was take some macrophages and incubate them with LDL and wait for the foam cells to appear, and it failed. So Steinberg and Whitstone, two other doctor scientists, were the guys who finally figured out, oh, it's the seed oils. And they have to be oxidized, and then we can make all the foam cells that you want. That's the paper that European Atherosclerosis Society references as this is the first step, right? There's no other explanation.